So students, now we are going to start our new chapter, which is structure of atom. Students, here I want to recall you few things from the earlier chapter, which was some basic concepts of chemistry. In that chapter you had studied about the Dalton's atomic theory and modern atomic theory. In Dalton's atomic theory you had studied that atoms are the smallest particle of a substance which cannot be divided further into simpler units. But in the late 19th century, this point of Dalton's atomic theory was completely discarded, and it was said that no, it's not true that atoms cannot be divided further into any simpler units. It can be divided into simpler units, which are protons, electrons and neutrons. Okay, so basically students, in this chapter we are going to study about all the aspects of protons, electrons and neutrons, and also about all the about the distribution of the electrons around the nucleus and the atomic structure, the shapes of the shells, and many more things related to the atoms. Okay, so first of all, here we are going to discuss about the electrons, how it was discovered, by whom it was discovered, and what were the experiments behind the discovery of the electron. First of all, one thing which you need to know is that it was discovered by J.J. Thomson. Okay, so basically electron was discovered by J.J. Thomson at the end of 19th century during the studies of the passage of electricity through gases at extremely low pressures. These experiments were known as discharge tube experiments. So why it was called discharge tube? Because in this experiment discharge tube was used. Here I have drawn a rough diagram of discharge tube for you. Okay, so this is what is your discharge tube. So basically students, discharge tube is a cylindrical hard glass. Okay, as you can see here that this is a shape of cylinder. So this is a cylindrical hard glass which is connected to two metallic electrodes. One is your cathode and the other one is your anode. Okay, which is in turn is connected through a battery, and here it is also connected through a vacuum pump. This vacuum pump is basically used for decreasing the pressures, or you can say it is used for controlling the pressure of the gas used inside the discharge tube. Okay, so now we will study about the cathode rays. Okay, so basically it was observed that under ordinary conditions gases are poor conductors of electricity. However, when a high voltage is applied to them at very low pressure, the gases becomes conductors and electricity begins to flow in the form of rays. These rays were called as cathode rays. Okay, and following observations were made during the discharge tube experiment. First one is when discharge tube contains any gas at normal pressure, then nothing is observed. Okay, so when the pressure inside the discharge tube is at normal condition, then in that case nothing was observed. Even if the voltage was increased from 5000 to 10,000 volt, but still it was not observed anything in that discharge tube, means that those gases didn't show any kind of conduction. Okay, so when in the next time when the pressure is decreased to about 10 raised to the power minus 2, the gas becomes conducting and the light is emitted by the residual gas in the tube. Okay, so basically when the pressure was decreased, then in that case the gas became conducting and the light was emitted, and when the pressure was further decreased in the discharge tube, it was observed that the glow becomes weak, and even it was also observed that on decreasing the pressure further, even the glow after some time disappeared. Okay, so these were the basic observations which were made during the discovery of the cathode rays. Okay, Now we will discuss about the properties, or you can say the nature of the cathode rays. First one is the cathode rays start from the cathode and moves towards the anode. Okay, this is the direction of the cathode rays, that the cathode rays start from cathode and move towards anode. Okay, so it was basically proven by an experiment in which an object was placed on the opposite wall of the on the side of the anode, and also it was observed that it casted its shadow on the wall opposite to the cathode. Okay, so this is how it was concluded that the cathode ray starts to from cathode and move towards the anode. Next property of the cathode rays is particle nature, or you can say that it produces mechanical effects. Okay, so basically students, cathode rays are particle in nature. So to explain this, they performed an experiment in which they placed a light paddle wheel in the discharge tube at the path of the cathode rays, and it was observed that the paddle wheel was moved by the cathode rays. So it was said that cathode rays have mechanical effects, that is, it is particle in nature. Next, in the absence of electrical or magnetic field, these rays travel in straight line. Okay, so means that if there is no kind of field, whether it is magnetic or electric, then in that case the cathode rays travel in straight line. Okay, also students, in the presence of electric field, it was observed that when these plates are given opposite electric charges, the beam of the cathode rays were deflected towards the positive side. Okay, so because of their movement towards the positive charged plate, it was concluded that the cathode rays are negatively charged. Okay, so this is a very important property of cathode rays, that the cathode rays have negative charge. Okay, and also when the cathode rays are made to pass through a magnetic field, these are deflected in the direction corresponding to the presence of the negative charge of the on the particle. Okay, so this is how it was this is how the cathode rays behave in the electrical and magnetic field. In the presence of electric field, it moves towards the positive plate, and in the presence of magnetic field, these are deflected in the direction corresponding to the presence of the negative charge on the particles. Okay, next one is it produces heating effects. So when cathode rays moves, it can also heat up the metal foil, gets heated to it because of it. So it is said that cathode rays produce heating effect. Okay, so these are the properties of cathode rays, that they start from cathode and move towards anode, and they also produce mechanical effect, and in the absence of electric or magnetic field, these travel in straight line, and electric field experiment shows that these particles are in cathode ray carry negative charge and they produce effect, heating effect. Okay, so these are the properties of cathode rays. Now we will calculate the mass of a electron. Okay, so basically the mass of the electron is calculated by the charge by mass ratio. E is the charge of the electron, and m is the mass of the electron. Okay, so charge by mass ratio is experimentally observed by the experiments. Okay, and this is the value of the charge by mass ratio, 1.758820 into 10 to the power 11 coulomb per kg. Okay, so this is the charge by mass ratio. Charge of the electron is 1.6022 into 10 to the power minus 19 coulomb. This you have to learn it, because this is very important. You must remember the charge of the electron. So charge on the electron is 1.6022 into 10 to the power minus 19 coulomb, and mass of electron we can calculate through the ratio of these two. Okay, so E upon E by m ratio, or you can say charge over charge by mass ratio, gives you the mass of the electron. Okay, so on putting the value of the charge, that is 1.6022 into 10 to the power minus 19 coulomb, upon putting the value of charge by mass ratio, which is 1.758820 into 10 to the power 11 coulomb per kg, we get the mass of the electron, which is 1.1094 into 10 to the power minus 31 kg. Okay, so this is the basic mass of the electron.